Earlier in this year at I/O, we launched photorealistic 3D maps in the Maps JavaScript API. This allowed developers easy access to rich 3D data using the familiar canvas of the Maps JavaScript API and the simplicity of a single line of code. In September, we added a set of new functionality to the product that allows developers to facilitate the creation of even more engaging solutions. Let's take a look around these new features and see how they can make your 3D maps more immersive, interactive, and most importantly, fun. Firstly, when developing 3D Maps applications, you need to be able to show where things are and make them stand out from the background. You also need to provide the ability for users to interact with these elements to get insights, select features, or just choose an element. Previously, you were able to add polygons and polylines to the 3D map. Now, you can add markers into the 3D scene. Markers can be customized in many different ways, from changing the color of the default pin, replacing an icon with your own symbol, or even anchoring the markers with an extruded line. Here you can see us use the pin element feature on a marker to style the background light blue, the glyph color red, and the background color a darker blue. We also set the glyph to be an E and extrude the marker up 50 meters relative to the ground. You can see how that looks here. This is only the start. You can create pin elements that can completely change the look of any feature as required. Markers can also trigger specific actions through the use of click events, responding to the user's engagement by displaying data in custom UI elements or searching for matches around the location. This is performed through the use of a marker 3D interactive element, which adds interactivity to the marker class. As you can see here, a click event can be attached to a marker, which can perform a task with the clicked event position. In this example, we can see a user click a marker. This then does a search for all of the schools in the area using the Google Maps Platform Places service. The position variable of the event gives the clicked location. This in turn is sent to a find schools function, which matches the location against the school type. The matched schools are then used as input into an add markers function, which adds the school markers using the SVG element from the place type as input to the pin element of the marker. Mixing different Google Maps services allows you to add intelligence to your application from user interaction in the scene. You can expand this to search for more feature types in order to provide a larger detail of context to any location. The ability to add markers can be used for all sorts of applications to allow users to uncover elements in the 3D map that leads to further investigation and ultimately higher levels of user engagement. Markers are all well and good, but sometimes you may want to add more interesting features that bring a higher level of detail or visual appeal to the experience. In this case, we can use the functionality to load GLTF assets directly into the scene to add more realistic elements. GLTF files are based on an open source 3D format that can be used to represent buildings, landmarks, or other custom objects and can enhance both the visual appeal and functionality of your maps. You can load them directly using the model 3D element class by specifying the location of the file. If you didn't create the model yourself, you can set the scale and orientation to make it fit the location. You can do lots of interesting things with models, especially when combined with animation functionality. Here we see how you can use a library to update the location of the model and a 3D camera based upon real-world location updates to create an animation of a plane flying into Innsbruck Airport in Austria. As you can see, the richness of the 3D map combined with the model makes the experience more immersive. While it's possible to animate the 3D map by working directly with the camera in the standard browser request animation frame method, this can be complex and take a lot of work just to add simple movement. When going from one place to another, animating the display to fly between locations makes the application seem more real than just appearing at the location. For this release, we added functions to fly to and fly around specific camera locations in the scene. The camera location can center on the location of a marker, or can be an arbitrary location in order to frame the scene. In this example, we use the fly camera to function of the map 3D element to fly to an end camera location specified in the options, in this case, a location in Hawaii. Note that we also specify the length of time it takes to fly to the location in terms of milliseconds. The other function allows us to orbit a location using the fly camera around method. Similar to before, it takes camera options to specify the location of the point to look at when orbiting. In this case, the time it takes to orbit the location is also based on the number of milliseconds, but this is also affected by the number of rounds it's going to rotate in this time, which is also specified. Note that you can link two animations together through the use of an event named AnimationEndEvent. Using this event, you can combine animations together sequentially. As you can see here, we set the once option for the event listener to true to make sure it is only fired once and we don't keep orbiting forever. Here we can see the methods in action. We first fly to the location in Hawaii, and then as soon as that animation has completed, we start to fly around the caldera. So there you have it. These are some of the key features to add to your application, whether you are building a 3D map at a global scale or just wanting to explore a single location. Photorealistic 3D Maps in the Maps JavaScript API has a robust set of functions to allow you to create a new level of immersion in your application. Thanks for watching. We really look forward to seeing what you can do with Photorealistic 3D Maps. Take a look at our documentation and demo application, and have a go at one of the code labs, and get immersing your users in 3D.